In this video, we're going to go through a few examples. One will be of a single replacement, and one will be of a double replacement. Last video, we talked about during a single replacement, A is going to replace B because A is higher on the metal activity series than is B. So the first question we're going to look at is question number 1 here, where zinc is reacting with hydrogen chloride. So the first thing that I'm going to do for this problem is I'm going to write out the reactants in their formula, chemical formula. So zinc, that is not a diatomic molecule, so it's just simply Zn. And Zn is going to be reacting with hydrogen chloride, and the formula for hydrogen chloride is HCl. H in this case is a 1 plus, Cl is a 1 minus, H from column 1A, 1 plus, Cl from column 7A, a 1 minus, so it's just HCl. So the question we have to ask ourselves, is Zn going to replace H? And the way that we know is if A, substance A, in this case, which is Zn, is it higher on the list? Is it going to replace B? So if A is more reactive than B, then it will replace it. So we look at our list here, the metal reactivity list. We find zinc. Zinc is located right here, and it's definitely higher on the list than hydrogen. So this reaction will take place. So the first thing I always do is I always write H by itself, or that substance B by itself. And in this case, H is a diatomic molecule. So we can't write it when H is by itself. It's not going to be just H. It's going to be H2. And now Zn is going to be connected with Cl because Zn replaced H. Well, Zn is a 2 plus, and Cl is only a 1 minus. So it's going to take 2 Cl's to match the Zn. So it'll be ZnCl2. So this is our single replacement reaction. The second one that I would like to do is I would like to do question number 1 from the double replacement. Barium chloride with aluminum sulfate. So once again, the first step for this, so this will be a double replacement reaction. This was a single replacement reaction. The double replacement reaction, we start with barium chloride. Well, barium is from column 2A, so it's a 2 plus. Chloride is from column 7A, it's a 1 minus. So the formula for barium chloride is BaCl2. It takes 2 Cl's to match the Ba. What I would like to do now is add, based off of our notes, what kind of phase is it in? Is it an aqueous solution, or is it a solid precipitate? So barium chloride, we're going to look at our solubility table. We're going to find barium. We're going to down to find chloride ion, and it is soluble. Since it is soluble, that means when we place barium chloride into water, it's going to dissolve into its individual ions, forming an aqueous solution. So we're going to put AQ on the end of that substance. Back to our problem for number 1. We looked at barium chloride. Now we're going to look at aluminum sulfate. Aluminum is in column 3A. It's a 3 plus. Sulfate is a polyatomic ion. The way we recognize that is the ending of ATE. So it's an SO4 with a 2 minus. When I put a 3 plus aluminum together with an SO4 2 minus, I'm going to need 2 3 pluses and 3 2 minuses. So it becomes Al2SO4 3. And I'm going to use my solubility chart to look up Al and to go down to find where it matches with the SO4. And it says that that is soluble. Because it's soluble, that means it's going to dissolve and it's going to form an aqueous solution. So I put AQ on the end. Now what we want to do is look at the pattern. The pattern is that A will go with Y and B will go with X. The reason we have to put B first is B is going to be the positive. So now we need to allow barium to go with SO4. Barium is a 2 plus, SO4 is a 2 minus. So when I put barium and SO4 together, it just becomes BaSO4. I go to my solubility chart and I look up Ba and I look up SO4 and something is different. This substance is insoluble. Because this substance is insoluble, the ions will not get pulled apart. It'll stay as an ionic crystal when we put it into water. It'll form a solid precipitate. And because of that, we put on S at the end. Now, I should have planned a little better to be able to add my second substance in, but I did not do that. So I need to add Al and Cl together. Al is from column 3A, it's a 3 plus. Cl is from column 7A, it's a 1 minus. So when you put Al and Cl together, it will be AlCl3. Now, when we look at our solubility chart, we find out that Al and Cl is soluble. That means since it's soluble, it's going to dissolve and form an aqueous solution. This is the pattern you will very often see. Two reactants beginning in the aqueous solution, and then one of the products forming a solid precipitate. This is what we're looking for. Is either one of these insoluble on the chart forming a precipitate? And the answer is yes. So yes, this reaction will happen. For single replacements, we make sure that Zn is higher on the list than H. For double replacements, we're looking at our two products and seeing if either one of those are insoluble. Now, we still have some work to do because we need to balance the equation. There's 3 SO4 groups. I would probably group these guys together. There's 3 SO4s over here, so I put a 3. Then I got 3 BAs, so I can put a 3 in front of the BA. But now that gives me 6 CLs, so I put a 2 in front of there. And now I have 2 ALs, and I have 2 ALs. I hope this helps with single replacement reactions, looking at the metal reactivity series, and double replacement reactions, looking at the solubility chart.